And so there are a number of applications for geoprocessing in GIS, including executing a geographic operation, for example, calculating the acreage for each parcel in Hays County, or clipping all rivers in Texas to the state boundary. We can use geoprocessing to automate a workflow. For example, reproject all of your GIS data to a common coordinate system, or clip all of your project feature layers to a project boundary. We can use geoprocessing to model a process. Maybe I have a quarterly real estate sales report that I'd like to automate. And last, we can use geoprocessing to perform a spatial analysis. For example, creating a slope map for the Bull Creek watershed or locating a spaceport site for launching rockets. And I'd like to expand on the spaceport site selection analysis to demonstrate how we can use geoprocessing to perform a spatial analysis. In the spaceport project you'll be working on, it was very similar to the site analysis that we viewed in the video at the very beginning of this lecture, in which there was a high-level national search and then a more localized site analysis. You're going to be completing the more localized site and feasibility analysis, but it began with a national search for a county in which to locate the proposed spaceport. And SpaceX wanted to locate the spaceport within the contiguous United States, reducing transportation cost, located close to the equator and oriented eastward, reducing rocket fuel cost, and located along an unpopulated coast, reducing risk to people and property. And it's our job as GIS analysts to take these site selection criteria and convert them into a GIS analysis. In this case, I can convert each of those to a GIS analysis utilizing the Select by Location geoprocessing tool. And so the first step is to locate counties within the contiguous United States. So I use the Select by Location tool and set the input features to counties, the relationship is intersect, and the selecting features to contiguous_USA, and click Apply, and you can see the results of my selection on the right-hand side. It selects every county in the contiguous United States. The next step in my spatial analysis is to locate counties close to the equator and oriented eastward, reducing fuel cost. This time, I use the Select by Location again, with the input feature still set to counties, but the relationship is changed to within a distance. I set the selecting features to equator and the search distance as 2,000 miles. And this is really important. I changed the selection type from a new selection to select a subset from the current selection. This allows me to utilize the selection set from the previous step in this step. And so I'm going to change it from new selection to select subset from current selection. And when I click Apply, you can see that results in only counties that are in the very southern portion of the United States, including counties in Texas, a few in Louisiana, and then some in Florida as well. My last step in the spatial analysis is to locate counties along an unpopulated coast, reducing risk to people and properties. And again, I have a coastline feature data set that I can utilize and the Select by Location geoprocessing tool. I have my input feature still set to counties, my relationship set to crossed by the outline of, and my selecting features to coastline USA. Again, I'm going to set my selection type to select subset from the current selection. So it selects from the selected records in Texas, Louisiana, and Florida. And when I click Apply, I end up with a very small selection of counties in which SpaceX is willing to locate their proposed spaceport. Now, I manually walk you through this process utilizing the criteria and the individual steps with the Select by Location geoprocess. But I can also diagram these individual steps utilizing Model Builder. So here you can see those same steps, but instead of a Select by Location pane, I'm utilizing Model Builder to diagram these individual steps. In which, for example, in the first step, my inputs are set as contiguous USA in the counties, select layer by location that intersects. My output is counties within the contiguous USA. Then I utilize the equator and the counties within the contiguous USA to select layers within a distance, in this case 2,000 miles, to create a subset of counties within 2,000 miles of the equator. And then last, I use that subset and coastline to select layer by location, cross by outline. So it's the subset within 2,000 miles of the equator, crossed by the USA coastline, and that gives me my candidate spaceport sites. And I can chain each of those geoprocessing steps together in a model. So here you can see my final model in which I could run and iterate through the model several times as I adjusted criteria like distance from the equator. Now, what is the difference between a spatial analysis and geoprocessing? Geoprocessing are the individual steps where you execute an operation on geographic data. Spatial analysis is where we put it all together and explore the relationship between geographic data. So this entire workflow represents my spaceport site selection analysis, and the individual steps are the geoprocesses. Now, every site selection analysis is unique, but we can use a standardized workflow like the analytical process: question, inform, analyze, decide, and present, to answer questions like, where is the best location for the new high school, the most attractive market for a new restaurant, or the best corridor for a new pipeline. So expanding on the analytical process, the first step, question, is to define the project criteria. Next, we inform our analysis by modeling the mappable criteria. Then we analyze our information by performing proximity and overlay analysis. Then we decide on what our results are telling us and refine our analysis. And last, we present our results by visualizing our criteria and selected sites. Our overall objective for this topic is to create accurate vector GIS data through proximity analysis. At this point, you should be able to differentiate between geodesic and planar measurements. Geodesic measurements are measurements performed on a spherical geographic coordinate system, and planar measurements are measurements performed on a flat, projected coordinate system. You should be able to measure feature geometry and classify by attribute. Feature geometry can be measured using the measure tool visually or by calculating the geometric properties of your features. We can also classify by attribute and symbolize the results. You should be able to list and describe different vector proximity geoprocessing tools, like creating origin destination links or buffering. You should be able to explain what the geoprocessing framework is, which is the larger framework within GIS software that allows you to access individual geoprocessing tools. From the ArcGIS Pro analysis ribbon, you can access geoprocessing models, scripts, commands, workflows, toolboxes, portal, and even your geoprocessing history. Last, you'll use vector proximity tools to perform common geospatial analyses like site selection and impact assessment.